Hello and welcome to this demonstration. My name is Wolfram Richter. I'm an enterprise solution architect with the German Red Hat Sales Organization. This demo is about showing how a day in a life of cloud users and cloud administrators could look like. It is based on the requirements sent to us by a client, and I do want to take you through the proposed architecture that we did for that client, and then I do want to run you through the demo, what it looks like today. If we look at the requirements and the functional architecture resulting of that, basically the cloud platform is supposed to be a multi-geographically rolled out cloud environment that could be the basis for the whole data center infrastructure across multiple geographical regions. And we've identified a number of systems that the cloud platform needs to interact with and a number of roles that are required. And of course, this is all very high level and could go into much more detail. So the cloud platform is in the middle, and it needs to interact with the administrators who do day one and day two operations with the cloud to install and manage it. Developers who create content that is offered via cloud mechanisms, the actual consumers who will utilize cloud resources, financial approvers who need to be part of approval workflows. And then there are a number of accompanying systems like existing network and storage, or a change in configuration management database, external cloud providers that could be part of a hybrid cloud scenario. You have source code management, email systems, identity management to control access, billing and rating or ERP systems. You have centralized logging frameworks and monitoring frameworks. You might have an IP address management backup. And I'm sure there are a number of additional scenarios that will and systems that need to be integrated once you look into it into more detail. The requirements we looked at basically were derived from the requirements document we got from the customer, and there are a number of very detailed questions, but you could categorize that. We want to, or the client wants to consume cloud resources. He wants to provide new service offers. He wants to install the cloud environment. He wants to manage it, to update it. He wants to change and reconfigure the cloud environment. He wants to manage resources provided on top of the cloud environment. He wants to view and plan the resource consumption. He wants to perform billing and chargeback. He wants to perform troubleshooting, and he's interested to learn about platform as a service and container support. And this is pretty much what we designed this demo scenario to address. From the architecture that we proposed, this is a very high-level conceptual building block diagram. So I think what's immediately obvious, we have the sideways T, this management platform that is responsible to manage the actual cloud infrastructure that lies below that. So we don't consider offering a bare metal cloud infrastructure. Rather, we say they need some sophisticated management tools to actually make the cloud infrastructure consumable. On top of the cloud infrastructure, and also partly managed through the management platform, are the actual cloud workloads. Basically any workload that is actually running on top of the cloud infrastructure. And on the right-hand side, you have interfaces and extensions, for example, to external cloud providers, but also to other systems. And here in the top, you have the various roles that interact with the system. If we drill down one level deeper, you can see why we laid it out that way. Central piece again is the management platform. Here it's split into two parts. It's the cloud management platform itself that is responsible to manage the underlying infrastructure. And you have on the left-hand side the systems management tool that is responsible to manage both the operating system workloads running on top of the cloud infrastructure, as well as is responsible to manage the actual cloud infrastructure components itself. And there's an interesting thing about the cloud infrastructure is that this is not a single uniform piece. Rather, in the vision that we understood the client has, is there are multiple cloud environments that need to be managed basically as a single framework. So this could be, for example, an OpenStack environment, but it will also be a traditional hypervisor environment, or maybe multiple geographically dispersed OpenStack regions. On top of the cloud management platform, you have the actual workloads. So the operating system, they basically represent any workload that is actually running on top of that. So it could be even more than just in the operating system. It could also be, for example, a full stack of components required to run an application. Here it's basically simplified just the operating system. And on top of that, we're talking about a container runtime, large-scale distributed container runtime, and on top of that, about a platform as a service. And either of them might integrate with a container repository, which allows us to actually store trusted container instances that are then deployed on the container runtime. On the right-hand side, you can see we've listed again the various different systems that we consider important to be integrated with the platform, and it's primarily the cloud management platform that connects to all the other different systems here. Going away from the logical infrastructure towards a physical implementation of that logical architecture. That is the next slide. We can see what we are proposing here. So we have Red Hat Cloud Forms as the cloud management platform that also integrates with the various other systems, that integrates with external cloud providers. We have Red Hat Satellite as the systems management and container repository. As cloud infrastructure, we see Red Hat OpenStack platform. So you can see the various OpenStack components like Nova, Neutron. In the management layer, you see KVM as a hypervisor. We position Red Hat Ceph Storage as a common unifying software-defined storage layer. And we decided to look at a large-scale deployable software-defined networking. And here we support multiple partners. One of them we're working very closely together, who has also helped us building this demonstration, is Nuage. So Nuage could be an integrating software-defined network spanning multiple OpenStack instances and multiple hypervisor deployments. As you can see, we have multiple of those vertical bars. So those represent, for example, multiple OpenStack environments, but could also represent, for example, a VMware vCenter hypervisor environment, or a Microsoft Hyper-V environment where SCVMM is the management layer, Hyper-V is the actual hypervisor, and Nuage could partially also act as software-defined network for that. On top of that, operating systems, the target architecture consists of Red Hat Enterprise Linux as Linux managed by Red Hat Satellite, or Windows managed by Microsoft SCCM as management platform. And on top of that, we have Red Hat Atomic Enterprise Platform as distributed container runtime, which is part of Red Hat OpenShift Enterprise as the platform as a service layer that adds container build automation to the distributed container runtime. So now that we've looked at the physical architecture of the proposed solution for the client, I would like to move into the demo. In the actual client presentation, we have looked more into the product a little bit more at this point, but let's move right into the demo. And the demo pretty much reflects what's just depicted here, with some minor differences. A lot of the actual infrastructure resides in a Red Hat Enterprise virtualization environment. So we have virtual systems that we connected together. And in our demo scenario, OpenShift Enterprise is not running on top of OpenStack, but is also running in parallel to OpenStack in Rev. Other than that, I think the demo scenario pretty much reflects what we have proposed here as a target solution architecture. So let's get started. Demo a day in the life with the Red Hat Cloud. As you can see, it is quite a ride that we're built here and that we're gonna take you with. The first thing is, whom do we focus on? Well, a key and a main star of the demo is, of course, the cloud platform itself that provides, in a self-service fashion, limitless compute capacity to the various different roles. And the key role is then the cloud consumer, who does not necessarily have to have the greatest technical expertise. He just wants to get his job done. He just wants to be able to consume certain resources, but should be enabled to have as limited exposure to the technical stuff as possible. For the technical aspects of the cloud is the actual cloud admin, and here we don't distinguish between a cloud developer, a cloud installer, a cloud operator. It's all the cloud admin. He has a very high technical expertise, and he has a key interest to ensure smooth operations. And the approver is basically a management role without technical expertise, but with financial responsibility. So for key decisions, the approver has to, well, approve. You will see the various different icons reflected again in the demo later on. So here is the actual flow through the demo that we've set up. You can see the backdrop, the conceptual model, and the red thread that runs through it. We have a number of different use cases. So we're starting in the management layer by the cloud consumer, who will order a service and will get that service then delivered through the cloud platform. We have set up a quota and approval scenario where you can see what happens if quota is exceeded, what happens if approval is necessary to get certain resources. We will then look at how to detect and how to handle security exposures and how an integrated management of the workloads is actually possible. We will then look into metering, showback, and billing to give the consumer an overview of what he has consumed and what that means in monetary terms. We will then move down towards the infrastructure layer, which is more the focus of the administrator. So we will then look into cloud capacity planning, and we'll identify that additional compute capacity is required. So we will look at what does it mean to actually add a compute node. We will then look at how to troubleshoot error scenarios in the cloud environment. We will look at how compute nodes can be updated, how controller nodes can be updated, what it means a high available OpenStack environment. And we will look at how to actually roll out a completely new OpenStack region, a new OpenStack environment. There we will move back into the cloud workloads itself. We will look at the distributed container runtime and look at platform as a service.